So what if we have functions that are multiplying together? So our product rule tells us that if we want to take the derivative of this first and second function multiplying together, we take the first function times the derivative of the second plus the second function times the derivative of the first. Order doesn't really matter here, but I just kind of keep that theme in my head. It mostly helps me make sure I take the derivative of everything correctly, but I think of this as first times d second plus second times d first. D meaning derivative. So first d second plus second d first. Anyway, I'll keep probably saying that as I work through this, mostly because that's how I remember this rule. Again, good thing would be to have a nice little note sheet of collecting these rules, and that should be on there so you can refer back to it. So there are proofs of all of these rules. I'm not expecting you to run through the proofs. It all ties back to that difference quotient. This is kind of a little quick proof here to show that it works. But there are plenty of videos out there with proofs. If you really want to know why this works, the proofs are out there. But I'm just kind of letting y'all take the rules and use them and just go ahead and trust that they work. Okay, so let's say we want to take the derivative of x to the 5th power just using our power rule. So with that exponent 5 would come out front times x to the 5 minus 1 power. And we're done. Yay! But what if we separated this up? Because x cubed times x squared is the same thing as x to the 5th. What if I applied our product rule to that multiplication of two separated functions? So if I took the derivative, I'm going to write my notation d dx of x cubed times x squared. So taking the derivative, I would take, so what I'm going to be calling first and second function. So x cubed is going to be my first function, x squared is going to be my second function. So like I was saying, I go first d second plus second d first. So first d second plus second d first. All right, and then we simplify down. So x cubed is going to stay there. This derivative of x squared is going to be times 2x. And then we're going to go plus x squared times the derivative of x cubed, which is 3 times x, and then 3 minus 1 for an exponent of 2. X cubed times 2x is 2x to the 4th, plus x squared times 3x squared is 3x to the 4th. Add them together because I like terms. There's our 5x to the 4th. Same thing. Of course, one was much quicker and we did not need to separate it out like we did, but it's a nice little example of using our product rule and getting to an answer that we know is correct with the simpler form. So let's get more complicated. Let's say we have these different scenarios where we have two functions multiplying with each other. So in these cases, we're kind of separating polynomials. Really, we could break this down so that we only had to use the power rule by distributing all of this. It would take a lot of multiplication in order to get a simplified form of f of x, but you should get the same answer in the end. As they get more complicated, there would just be a lot more multiplying to do, but you could simplify it. But let's use the product rule. So I have this first function and second function, and I'm going to take the derivative. So the derivative of this overall function, I'm going to have first d second and plus second d first. Let's see, the first is 4x minus 3. Okay, so our derivative is equal to 4x minus 3. We're going to keep that in parentheses there. And then the derivative here, so I'm going to use the power rule on, well, really I have these three terms that I'm going to use the derivative on. So 2x squared, so we'll have 2 times that exponent of 2, which is 4, times x. And that exponent of 2 goes minus 1, so we're left with an exponent of 1. And then derivative of 3x will just leave us with a positive 3. And then derivative of the constant 5 just turns to a 0. And then we have this addition separating them. Be sure to keep that addition in there. Then we have this trinomial, so 2x squared plus 3x plus 5. And then the derivative of 4x minus 3. So you could think of it as going across those two pieces. Derivative of 4x will just leave us with a 4. Derivative of that constant, negative 3, just turns into a 0. So all we have from that is a 4, which makes sense too because that is a linear function, so we would just be left with that slope. All right, now we simplify. So over here I'm going to FOIL. So 4x times 4x is 16x squared. And then 4x times a positive 3 is positive 12x. And then we'll have minus 12x, so those are actually going to cancel out. And then negative 3 times positive 3 is a negative 9. So that's a difference of squares there, so that's why those positive 12x and negative 12x cancel out. Let's see, we have addition. Really, I should keep parentheses here, but they'll drop pretty nicely since this is all positive. But that 4 is going to distribute through. So 4 times 2x squared, 4 times 3x, 4 times 5. And since that's all positive and we're adding, that's just going to drop those parentheses. Okay. So let's see what like terms I have to finish this up. 16x squared plus 8x squared will be at 24x squared. We have this plus 12x. And then negative 9 plus 20 should be a positive 11. And we're done. That's it. So this uses the product rule, where you keep the first, take the derivative of the second, plus keep the second, take the derivative of the first. I'm going to keep going through examples here. If you feel like you got it, you're welcome to work on ahead, or you can pause the video and try these out for yourself, and then watch the video to check your answers. Those are all good methods to use. But with these, I think the more practice you get, absolutely the better. All right, we have our first function, our second function, and they're multiplying together. So to take the derivative, we're going to take the first function, 3x squared minus x plus 5, times the derivative of the second. So we're taking the derivative of x squared plus 3x minus 9. And then we're going to add that with the second function, x squared plus 3x minus 9, times the derivative of the first function, which is 3x squared minus x plus 5. All right. So we're going to have, in parentheses, 3x squared minus x plus 5. In my second set of parentheses, I'm going to gather the derivative. So derivative of x squared is 2x. And derivative of 3x is just 3. And derivative of a constant negative 9 is 0. So we're left with 2x plus 3. And then addition with, in parentheses, x squared plus 3x minus 9. And the derivative, so derivative of 3x squared, we're going to have a 3 times 2 for 6 times x, and then that exponent's a 2 minus 1, which is just an exponent of 1. So we have 6x. I'm glad we're seeing this one. So you can think of this as, so minus x is the same thing as negative 1x. So when we take the derivative there, really we're just going to be left with a negative 1. So again, when we have x there, that goes away because it would end up with an exponent of 0, which is just equal to 1. And then derivative of positive 5 is a 0. All right, then we're going to simplify. So our derivative, I'm going to get some distribution practice here. So like this 3x squared minus x plus 5 times 2x plus 3, what I do is I think of distributing the 2x and then distributing the 3. So usually I start with the smaller of the two and just think about distributing each piece. So distributing 2x, we're going to have 6x cubed, and then negative x times 2x, negative 2x squared, 5 times 2x plus 10x. All right, distribute the positive 3. 3 times 3x squared, negative x times 3, 5 times 3. All right, plus, and now same thing over here. So I'm going to distribute 6x into the trinomial and then distribute negative 1. So x squared times 6x, 3x times 6x, negative 9 times 6x, and then distribute the negative 1, so we'll have a negative x squared, negative 3x plus 9. Again, that second one I put all in parentheses, which is just good habit for when we have subtraction of pieces, but since this is addition, we can just drop those parentheses. And now it's the hunt for like terms. So I'm going to look at cubes first. So I have 6x cubed plus 6x cubed. So that's a 12x cubed. Let's look for x squared. Negative 2 plus 9 is 7. Plus 18 is 25. Minus 1 for 24. Minus 24x squared. Let's see, just regular x, 10x, minus 3 is 7, minus 54, calculator to help out there, 10 minus 3, minus 54, minus 3 is a negative 50. So I'm going to go minus 50x. And then we're going to have positive 15 plus 9 for 24. And we are done with that one. All right. One more example here with the product rule. Okay, we have our first function is the 4x cubed minus 11, second function of x plus 3. And this would be good to pause the video, try out that product rule, and then check your answer along with the video. So, taking the derivative, we're going to have first times d second plus second d first. And if you're ever unsure if you've applied the rule correctly, the theme that's occurring is you have one of the originals times the derivative of the other, and then plus, and it should switch it up, plus the original of the other times the derivative of the other that hasn't been taken the derivative of yet. All right, this one should be fairly nice. So we're keeping that 4x cubed minus 11. Derivative of x plus 3 is just going to leave us with a 1. Again, that's linear, and you could think of it as like a 1 times x. So that's just going to turn into 1, and multiplying by 1, that's just going to leave us with the 4x cubed minus 11. Oh, that's nice. Okay. Plus, and then we have x plus 3 times the derivative of 4x cubed minus 11. So when we take the derivative of 11, that's just going to turn into a 0. So really, I just need to focus on this derivative of 4x cubed. So 4 times 3 is 12. Then we'll have x, the 3 minus 1, so 2. So we'll need to distribute this 12x squared here. So for the derivative, we have 4x cubed minus 11. And then we'll have plus x times 12x squared, so a 12x cubed. And plus 3 times 12x squared, which is 36x squared. Oh, yeah. And then combine like terms. So 4 plus 12, so that'll be a 16x cubed. And we'll have a plus 36x squared. And then minus 11. All right, that's our product rule.